This is Algebra 2 with Trig, 1C.3. We're going to talk about complex numbers. Now, complex numbers is this whole idea about what happens when you try to take the square root of a negative number. Now, we would typically say that there's no real solution. If you take a calculator and you try to do the square root of -1 or negative anything, you're going to get a no real answer error in your calculator. You can't take the square root of a negative number. So instead of having the square root of -1 be in the problem, we're going to pull that out and just make it I. So square root of -1 is going to become this I version, and we like to make the I with a little tail hanging off the edge. Okay? And we'll discuss later why I squared is actually the number -1. Here are some rules or some properties that we're working through. When we're taking the square root of a negative number, we're going to write it with I in the front and then the square root of that number. So you no longer have the negative. You can't leave a negative inside a square root. We're going to cover it up, mask it up, by just using an I in front. So for example, we'll use the square root of -3. If that's your answer, we're going to pull the negative out and treat it as an I, because that represents the negative inside the square root. And then we still have the square root of 3. And then we'll talk about how to deal with squaring. We're going to square I. That's going to give us the value of -1, and you square root, and you get the value that's inside. All right, we'll practice some of those. So here, we're going to solve for x. Okay, if you think about it mathematically, x squared is up here, and -13 is down here. They never cross. There is no solution for this, no real solution. But we're not willing to accept that. So we'll still take the square root, just like we would on a normal x squared type problem. And we can factor apart our -13 into -1 times 13. That's a property we've learned before. We can break the radicand apart into its factors. We learn, I should say plus or minus. My fault. That equals plus or minus the square root of -1 times the square root of 13. We learned the property that you can break apart the two factors into radicals. And then what is the square root of -1? It is the value of I. So we get plus or minus I root, or square root, 13. You go ahead and start to set this one up. Give it a try. You can pause the video and try to start setting this up. Ready, go. So, of course, you would say subtract 18. Collect your like terms first. So that's -90. Then we divide by 2, because we're trying to isolate our x squared. So we're going to take the square root of x squared, and we're going to take the square root of -45. So that gives us x equals plus or minus the square root of negative 1 times the factors that make 45. You might be able to do this in your head, but 9 times 5 makes 45. So our final answer is going to be plus or minus 3i root 5. You take the square root of 9. The square root of negative 1 is the value of I. So you get plus or minus 3i root 5. It's all the same math we did before. If we were taking the square root of 45, we would have gotten the answer of 3 root 5. Now, because it's negative 45, we get the answer of 3i root 5. Now, that's one way that we can use imaginary numbers, okay, in solving equations. We can also have imaginary numbers come up in simplifying. So these are called complex numbers. Any number that can be written in the form of a plus or minus bi, where a is the real number and bi is the imaginary number. So notice that what we're trying to show here is that the imaginary number has to go second in the binomial. It has to be written second. You put the real number first. So I need you to think about this. So many people get this incorrect. What are you going to do? Go ahead, take 15 seconds to work on this question and start setting it up. Pause the video. All right, what I notice here is that we have two binomials that are adding each other. The common mistake is that two binomials, people want to FOIL this. You cannot FOIL this. You will not get the right answer. You must add them together. So really, we don't need the parentheses at all. If you want to think about it as distributing a plus, you're welcome to do that. 12 minus 11i, no need for parentheses. Negative 1 times, actually, positive 1 times negative 8 is just negative 8, and positive 1 times positive 3i is positive 3i. Now we have our like terms. These are our like terms. We get 4, and these are our like terms. And we get negative 8i. And that's our answer. Okay, we move on to the next one. Go ahead. Take time to work on this one. Make your decision with the important steps to take. Pause the video and give that a try. Okay, I noticed the minus in the middle. This is two binomials that we are subtracting. So you could say that you have 15 minus a positive 24. So you're subtracting 24. Or, most commonly, we're going to distribute that through 15 minus 9i minus 24 plus 9i. This makes negative 9. And a negative 9i and a positive 9i gives us nothing. They cross out completely. So it's just negative 9. So we flip over. And we're going to be multiplying complex numbers. Now, with multiplying complex numbers, some strange things can occur. Let's take a look and see what happens. What am I going to do here? only thing we can do is distribute. Just normal math. Negative 5i times 8 is negative 40i. And then negative 5i times a negative, that makes plus. 5 and 9 make 45. I and I make I squared. Now I squared's weird. So let's talk about what I squared is. Let's think about what the square root of 3 times the square root of 3 would equal. That's going to make 3. And the square root of 5 times the square root of 5? That's going to be 5. So what's the square root of negative 1 times the square root of negative 1? That is going to be just negative 1. For all the reasons, root 3 times root 3 is 3. Root I times square root of negative 1 times the square root of negative 1 is just 1. So if you have I squared, and you know that I means the square root of negative 1, that means you're going to convert it into negative 1. You cannot have an answer that has I squared in it. Nobody's giving answers with I squared. We can fix that. We can clean that up. We can keep simplifying that. I squared is negative 1. Now, it's not 45 minus 1. It's 45 times a negative 1. And I notice that this is not in the correct order, so I'm going to bring my negative 45 first and my negative 40i second. That would be the correct way to leave your answer. Think about what we did. We did our normal distribution, our normal calculations. We converted our I squared over. That's the 11th grade math that we're doing right now. That's the Algebra 2. And then we converted it, simplified this the rest of the way. Let's try this one. What do you see here? This is definitely multiplication, 2 binomials. So we're going to use FOIL. This type gets FOIL, not the type with a plus in between. So FOIL says multiply the front of the binomials. That's negative 32. Multiply the outer parts of the binomials. That's positive 56i. Multiply the inside of each binomial. That's positive 8i. And then multiply the last part of each binomial. That's negative 14. I times I is I squared. So we have our like terms we'll collect. So negative 32 plus 64i minus 14 times negative 1. We don't leave the I squared as I squared. We convert it to negative 1. And negative 14 times negative 14 is positive 14. Now, when I subtract these, it seems like people have troubles working with negative numbers. Okay? I see that the two signs are different. So that means I'm going to be subtracting. In my head, I'm thinking 32, take away 14. I take 32 and I take 10 away. That gets me down to 22. I take 4 more away. That takes me down to 18. So negative, because a larger number is negative, I know my answer has to be negative. Negative 18 plus 64i. That's your answer. You got to have it in the right order. And you need to simplify your I squared. And our last part, it goes with something else we've done this year already. We're going to divide complex numbers. When dividing complex numbers, you should multiply both the numerator and the denominator by the conjugate. We've talked about the conjugate before. So if we have the number a plus bi, imagine that, a plus bi, what's the conjugate of a plus bi? A minus bi, exactly. That's the conjugate. Just change the sign. So, how are we going to do that? We see our denominator has 5 minus I. We've learned before that you cannot have a radical in the denominator. Well, I is kind of like a radical. It's the square root of -1. You can't have that in the denominator. That's what we need to get rid of. That's why we can't leave it like this. So we're going to multiply 5 plus I to the bottom binomial and the top binomial. So you're thinking about what you do next. What seems reasonable? How do you handle it? Three times 5. If you can do this math now, since you see, oh, okay, we're going to FOIL it. You go ahead and FOIL it. Don't sit there and copy. So we FOILed together the numerator. We got I squared. We'll simplify that down. We'll clean it up. On the bottom, we have 5 and 5. 5 and I. 5 and negative I. That's the whole thing that the conjugate does. Conjugate crosses these two out. A positive 5i and a negative 5i. Makes no i's. And then negative and a positive, I and I, makes I squared. So our like terms tells us this is going to be 23i with 15 sitting in front of it, plus 4 times -1. 25 minus a -1. Well, this is 15, and this is 23i. This is -4. This is 25 plus 1. Because when you minus a negative, that's really adding. So we can collect our like terms. 11 plus 23i over 26. Is this considered an imaginary number? Okay, sure it is. So how are we supposed to leave imaginary numbers? With the real number first, 11 over 26, and the imaginary number second, 23 over 6. That's 11 over 6. This is 23 over 6. And it's I. That would be your final answer. This one you need to break into two parts. The radicals we do not. Radicals were done very similarly. And we're set.